Welcome everyone to this video. We have a question of thermodynamics in this paper. Uh, Question is rather straightforward. You have a substance whose specific heat capacity varies with temperature. Uh, so the specific heat capacity dq, if we ask what is the general formula, that is mass specific heat capacity change in temperature dt. This is the heat supplied. So we are supposed to raise the temperature of this gas from minus 73 degrees Celsius, that is 200 Kelvin, to 300 Kelvin. Specific mass of the gas is 1 kg, specific heat is kT, and change in temperature dT. So what is the heat which we require in this case? So after integrating, this value will come out to be some 2500 K. So that is what is asked in the question. I can show the integration as well. This is kt square by 2 and the limits are 200 to 300. So this is k 300 square minus 200 square upon 2. So this would be 25 2500 uh, k. So the value of n is going to be 2500. Side by side, we also want to do question number 9 as well. Or at least we want to discuss what is the principle. So we have a disk of mass m and radius r. It is free to rotate about its vertical axis, and there is a battery operated motor uh, which is fixed to the disk at a point on its circumference. Initially, both the disks are at rest. Now, as the motor is switched on, uh, the disk rotates at an angular speed omega. If the angular speed at which the disk rotates is omega by n, what is the value of n? This is a classic question where we have to do conservation of angular momentum of the smaller disk and the bigger disk. So the smaller disk will have two components of angular momentum. One of the components of its angular momentum would be the orbital one. So we'll say L orbit of the smaller disk, which would mean angular momentum, moment of inertia of the disk about its axis into the angular speed omega, plus the angular momentum of the this is the angular momentum of what we say, yes, orbital angular momentum is mvr. Orbital angular momentum, and one is spin angular momentum. So when we talk about spin is about its own axis, so that is I omega, and the orbital angular momentum would be some mvr. So the spin angular momentum would be in opposite sense to the orbital angular momentum, and the angular momentum of the disk also would be in opposite sense. The I disk, that is the bigger disk, into some omega dash. This v into r can be written as omega r or omega dash r. V would be written as omega dash r because that is what the center of the disk is traversing at. At that speed, the center of the disk is going. M is the mass of the disk, which is same for both the things. After this calculation and keeping the signs carefully, keeping the signs, we should get our answer. So thank you for joining.